Alright students, so we are talking about sequences, specifically evaluating sequences. And you may not even know what a sequence is. Here we go. Well, a sequence is an ordered set of numbers. That's it. We use the squiggle bracket here, the little curly bracket, then we list the numbers separated by commas, and maybe use a dot 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 to say that they go on forever. A sequence can be infinite or it can be finite. So I guess, well, to be perfectly mathematical, I mean, normally this squiggle bracket here means set, and so this would, I guess, this would mean that this is the set, but I'm going to use those squiggle brackets to identify that this is the beginning and it goes on in this direction or whatever. But sometimes if you just see the sequence, sometimes you'll see them without the squiggle brackets, so I probably should not include that. I guess the official answers and whatnot are just going to have list the numbers, but anyway, so that would be the set containing these numbers. But in any event, this is the first term, this is the second term, so we normally use the letter A to represent the different terms in a sequence. So this is A1, A2, A3, or sometimes we might say A sub 1 or A sub 2, and so on and so forth. And they don't have to be whole numbers. I mean, they could be fractions like 1/2, 2/3, 3/4. So what else can we do with a sequence? You can have an explicit formula where it's like explicitly or very clearly lays out what the terms are for a sequence, such as we could say that the a sub n, or the nth term, is equal to maybe 10 plus 2n, where n is 1, 2, or 3. And in that case, you could build the sequence. So rather than having the sequence already listed out for you, you have this formula, and then you could say, well, a sub 1 is 10 plus 2 times 1, so that would be 12. And a sub 2 would be 10 plus 2 times 2, which is 14. A sub 3, 10 plus 2 times 3 is 16. So 12, 14, 16. Okay, yeah, I really should have erased those squiggle brackets, but whatever. There you go. 12, 14, 16. That's the sequence. Technically, once again, those squiggle brackets mean it would be the set which contains that sequence, but we're fine. Here's what your problems will look like. This says find the first 4 terms of the sequence, and they give the explicit formula. A sub n equals 31 plus 8 times the quantity n minus 1 for values of n equals 1, 2, 3, and so on and so forth. So we're counting numbers here. So a sub 1 is just going to be 31 plus 8 times 1 minus 1. That term there will go to 0. So that's 31. Then a sub 2 is 31 plus 8 times 2 minus 1. So that's going to be 39. A sub 3, 31 plus 8 times the quantity 3 minus 1, so 8 times 2 is 16. So I get 47. I'll do the next term here in a second. But one thing that's kind of interesting, we can see in this sequence we have a difference of 8 between each one of these. So 31 plus 8 is 39. 39 plus 8, 47. If we do the next term, it's going to be 55, which incidentally is 5 more than the previous term. This type of sequence is called an arithmetic sequence. It's when you have a common difference, a common number that's added to the previous term to get to the next term. And this one has a common difference of 8, so we would say d equals 8. And up here I'll write those numbers: 31, 39, 47, 55. Yeah, there you go. That's good. This is a sequence. The other thing with the squiggles is the set with containing those numbers, but there we go. So once again, we've got more of these. Just there's the explicit formula, plug in the values, and you're good to go. All right, let's go ahead and look at a different type of problem here. So same thing, first 4 terms, but we can see this formula looks a little bit different. We've got that n there up in the upper right-hand corner. So we'll say this is going to be 3 times 4 to the 1 minus 1, so 3 times 4 to the 0. 4 to the 0 is 1. So 3 times 1 is 3. A sub 2 is 3 times 4 to the 2 minus 1, so 3 times 4 to the first, so that's going to be 12. A sub 3 is 3 times 4 to the 3 minus 1, so that's 3 times 4 squared. 4 squared is 16. 3 times 16 is 48. And then a sub 4 is 192. What's interesting about this sequence is that if you multiply the term, each term by 4, you get the next term. So 3 times 4, you get 12. 12 times 4, 48. 48 times 4, you get 192. There's a special name for this type of sequence. Oh, I put those squiggle brackets on there again. Oh well. It's a geometric sequence. That's when you're multiplying something, by multiplying a term by the same number each time, and you get the next term. And we would say that that number is called the common ratio. And in this case, our common ratio is 4. We'll dig a lot more into arithmetic sequences and geometric sequences in subsequent videos and homework assignments. So those are the big two. Wanted to show you one more here that's kind of interesting. Another type of sequence. So this is we've got a -1 and then n plus 1, and then you have a n term here. So this creates sort of an interesting phenomenon. So when n equals 1, we have 1 plus 1 here as the exponent. Well, 1 plus 1 is 2, and -1 squared is a positive 1, so this is just like 1. And then you have 2 times 1, so this is 2. When we have a sub 2, we have -1 and then 2 plus 1 for the exponent here times 2 times 2 squared. So that's going to be -1 to the third power times 2 times 4 here, because that's the 2 squared. Now if you know -1 to the third power, so that's -1 times -1 times -1, well that's -1. So we have -1 times 2 times 4, so that's -8. So that's kind of interesting. We went from a positive number to a negative number. Let's see what the future holds for us here. So a sub 3 is -1 to the 3 plus 1 times 2 times 3 squared. So that's -1 to the fourth, which a negative times a negative times a negative times a negative. So that's a positive times a positive, which is a positive. So 2 times and then 9. So we have a positive 18. So this is kind of cool. We went a positive, then a negative, then a positive. We can probably make a prediction here that this next term is going to be -1 to the fifth, and since that's an odd power, then we're going to end up with a -1 for this term right here. 2 times the 16, so it's going to be -32. And this, we can say, all right, maybe this is geometric because I could multiply this times a -1, this times a -1, right? From 2 to 8, I multiply that would be times a 4, so like a -4. From 8 to 18 is like a 2. Well, no, that's not 2. That's not quite. It's like, that would be 16. I don't know why I wrote 2 there, but whatever. Yeah, so we're not seeing anything really consistent here. So this is a neither. It's not, we're not adding the same thing. We're not multiplying by the same thing. Apparently we don't even know how to multiply by 2. But yeah, it's a neither. We do have a name for it. We would say it is alternating because it's alternating sign plus or minus. But there you go. So that's our introduction to sequences. Basically just finding those terms, plug those into a table, plug those into the calculator, and you'll be able to find those values. And hope you enjoy working with sequences. Thanks for watching.